Hi, this is Jack Dowling, and I'm here today with Ron Dagdag. And Ron and I met recently. It was at one of the Dallas-based meetups, and he was doing a presentation on AI edge computing. And historically, Bodum has been involved in edge computing for quite some time, and I've been very interested to to see somebody actually presenting AI at the edge, and Ron was doing that. So, as part of these sessions that I do, every time I do one of these, I want to ask the person who's presenting to kind of walk us through their background, because I think the way a lot of people get into their careers is they meet people who are already doing what they want to do, and they understand how they got from what they majored in college, and then what kind of jobs they had that actually positioned them to be doing what this person wants to do for a living. So with that, Ron, I'd like to ask you to just kind of walk us through, what was your major in college, and then when you got out, what were your jobs leading all the way up to the job you have today?
Yes, my name is Ron Dagdag, and I went to school in the Philippines. I'm a bachelor's degree in computer science, and my career, I moved here in the U.S. back in year 2000, and I started as a software engineer mostly for the last 20 years. Most of my career is in manufacturing systems, driving a lot of digital transformation. And then for the past few years, I've been working on IoT systems, connecting with Alexa devices, Google Home, and then lately working with edge computer vision systems, and now being as a manager.
Great. Okay, so I want to kind of explain, why I was so interested in edge computing up front, and why I think it's going to be such a big part of the AI world. My experience in edge computing in the last 17 years has all been around automatic identification data capture devices, that read barcodes, RFID, GPS, and that type of thing. They're operating out on the edge of the enterprise, specifically in the oil and gas industry. And for some time, I've had it in the back of my mind that there's an opportunity there, and not just in that industry, but in a lot of industries that use edge devices to do AI at the edge. And so I want to talk through just real quick some applications that I think are going to be very powerful in that arena. Certainly real-time analytics, at the edge, faster decision making and improved response time. Object detection, used to detect objects in real time. It can be used for a whole bunch of stuff. Security, surveillance, logistics. Machine learning, which is what we're going to talk about tonight, can be used to make predictions and decisions, and things for like predictive maintenance and things like that, where you've got a device that could potentially be in the process of having a catastrophic failure, and yet if you have sensors on that device, you can detect it before it happens and actually shut the machine down. And then natural language processing, AI can be used at the edge of the enterprise, which, customer service, translation, fraud detection, interactions between humans and machines. So some specific examples of how AI is being used at the edge today, so you can realize we're not talking about something that's way off in the future. This is being done right now. Self-driving cars, they use AI to process data from sensors, which is exactly what Ron's going to show you tonight, such as cameras and radar, to make decisions about how to navigate the road. The data is often processed right there in the car to reduce latency and improve safety. So if you've got an emergency, you have to take emergency action. The car's got to be able to do that right then and there. Yes. And then smart cities, they have sensors, they collect traffic information, weather information, social media data, and it's used to improve city services, like traffic management, energy efficiency, and public safety. And then industrial automation, it's being used in manufacturing, logistics, and energy production, and it can improve efficiency, reduce costs, and improve safety. So that's, those are things that are happening right now that are already being done. And I think the number of applications for AI at the edge, it's a frighteningly broad field. And it's something that all of us are going to start to see. As far as people, interacting with AI in the public setting, a lot of it's going to be AI at the edge as we continue to go forward and grow the AI industry. So with that, I'm going to turn it back over to you, Ron. I'm going to make you the host here, and then you can dive right in and run people through your presentation.
Sure, I'll do that. Okay, let's get started. So today I will be talking about machine learning in small, low-power device. Sometimes it's called TinyML. My name is Ron Dagdag. I used to work with Spacey, and I am also a Microsoft MVP, the word categories in AI, Windows, and Internet of Things, and mixed reality. Currently, I work at 7-Eleven as an R&D manager. So today, my agenda, I will be talking about what is machine learning, a little bit about embedded machine learning, and then we will talk about the small low-power devices and the challenges of TinyML, and I will do a little demo on this device. And in between, I will talk about tiny things like one of these. This is world's tiniest chameleon, and notice how it's the end of the fingertip. And it's amazing how nature, not just big things, but also small things that are there's amazing. So let's go back to programming. What is programming? Typically, you would need two things, right? You have your input, and then you have to write the algorithm. In this case, we are building a calculator, and you need your input. What is the algorithm to do the calculator? And then it would spit out answers. On machine learning, the goal is to teach the machine to learn an algorithm. But in order to do that, you need two things. You need input, lots of examples of input and answers paired up together, and then you can train the device and it would build an algorithm for you. So as an ML primer, programming on the right side of the screen, where you have your input algorithm and then answers. On the left side, where you have machine learning, where you have input, answers, and algorithm. In machine learning world, we call that training data. And data is gold these days, and being able to get lots of training data and you pass that into training framework, and then it would build a model for you. And the model is what you would use into your application. And in order to use that, we call that in machine learning world, we call that inferencing. And you need an inferencing runtime to use that model, incorporate it with your application, and it will get the answers for you. So that's a good machine learning primer. A lot of examples out there when you're wanting to learn more about machine learning, they all focus on the training data, the training framework. And for me, the way I learned about machine learning is on the other side, the inferencing side. And today I'm going to demo a little bit more about TinyML and running on these devices on the inferencing side. Here's another small thing. This is an artist that creates tiny sculptures. I don't know how these tiny things got folded, but it's amazing thing to see how some people get creative from a piece of paper. So different applications of machine learning. We know that a lot of cameras these days, the phones that you use, it has a way to do machine learning on it and do us able to detect faces and all that. And also sound. You can have some data, or you can have some you can transcribe from sound, and then of course up and down, meaning it is being able to get some reviews and analyze those reviews and then have campaigns and all that. And a lot of websites uses machine learning to be able to analyze those reviews. In terms of Internet of Things, there are two major components or major goals of Internet of Things. One is being able to remotely monitor your devices. That's when you start gathering data and do some device processing and device status. And then another one is to control a device, meaning being able to send data to it and set some device properties. Today, a lot of the machine learning is happening on the device processing side, and you want to monitor that, and that's when Internet of Things come in. And when you want to learn more about Internet of Things, there's typically two paths that is available out there. It's either you want to use a Raspberry Pi that has a microprocessor, right? It has a whole operating system, a Linux operating system typically. And then, of course, there's these Arduino devices that are available out there that you would need a microcontroller in order to control, in order to do some programming on each one. So Raspberry Pi, typically you can run Python, you can run these higher level devices. On these microcontrollers on Arduinos, you may have to work with C++. And then I also want to talk about, the difference between information technology versus operation technology. Information technology, a lot of developers are familiar with, help desk, working with the cloud, a lot of the typical internet of the information technology and internet technology that we have out there relates with IT. And then you have the operational technology, which is these edge devices, or these devices that runs the factory or runs hospital, these or a lot of these devices that deals with SCADA, IoT, sensors, different actuators, and they all deal with operational technology. There's someone keeping up to making sure that these things is operating properly. And so IoT is the merging, or the combination of IT and OT, and that's whenever we have an IoT project, you got to think about these different user roles. One is the administrative role, where they are the ones handling the administrative task, different roles, different permission. And then the device developer, they're the ones who are writing the code for these IoT devices. And that's what we're going to be focusing today, is on the device developer side. And I just wanted to kind of showcase, as the machine learning running on a device. And typically that's a device developer's job. And then there's the operator, where the operators are the one manages the devices connected to IoT cloud application. And then, of course, a solution builder, which is the one that builds that connection between a device into the cloud, and what data needs to be collected in between and sent to other systems. So typically when you started, in IT, a lot of it is data that is collected in all these different servers, and machine learning used to run on a lot of these cloud servers. And then we started moving from cloud to mobile devices. I don't know if you've noticed lately, a lot of these mobile devices have started to be smart enough that it can run some machine learning workload. That's how they're able to get these devices to know if they're being used or not, to make it very efficient in running, so that you can have better battery life, for example. And then for mobile, we started moving to these Google Assistant or Alexa devices, where you can send commands to these devices, and then it would respond back. right? And a lot of those, is running a machine learning workload that's listening to the wake word. And the wake word typically is either Alexa or Google, okay, Google. And it would prompt that to send some data up to the cloud. Nowadays, with all the different technologies that's happening, more and more devices, some of these edge devices that are example over here, have become and we've added more edge computing and become more powerful, that it can run some AI and machine learning on those. One good example is the AirPods, and also your watch that you're using. Those are IoT devices. Toothbrushes are becoming more smart and able to detect if there are how it's being used. And then some of the kitchen appliances that we have out there, that's becoming smarter and smarter every day. So Internet of Things IoT 1.0 is the Internet of Things, but Internet IoT 2.0 is the intelligence of things. It's what we start adding machine learning on different things. Of course, it has constraints. You got to think about bandwidth whenever you start working on adding intelligence on these things or in these devices. We have to think about reliability. Not just that, it also talk about latency, different privacy issues, and then energy, right? Because these sometimes machine learning workload can consume a lot of energy, and so there's the balance of, is it really worth running it on that edge device that it uses a lot of energy, and it may not be as mobile or as useful anymore because on the different workloads we're adding there. So TinyML is all about data intelligence on sensors, right? It's not just motion. There's a lot of sensors out there, and each one of these sensors, you think about the sensors in your car, and there's a lot of different sensors to make sure it runs properly. And adding intelligence on those sensors would make it more powerful or make it better for us. So another side note about this painting, these are miniature painting on a piece of rice. So it's amazing how some people can do this and do some painting on a rice grain.
I love the Mona Lisa on there.
Yeah, it's
really
amazing.
Great. Yeah.
And some of the examples out there of how it's being used, how TinyML or machine learning at the edge is being used right now. One great example is the keyword spotting. Like what I said, these Alexa and Google devices, it's actually running these TinyML or these machine learning on the edge, and just listening for a certain keyword, and then it would send a signal to start recording. And then another is this visual wake word. And visual wake word is being able to detect, is there a person right in front of the camera? And if there is, and then it can be another trigger to do something. And it's not being sent to the cloud, it's just locally running on that machine, on that edge device, and continuously running. Another one is anomaly detection, like what Jack was talking about, is being able to detect, do predictive analytics at the edge. And then, of course,
I was going to say, an example of anomaly detection where you might have edge computing. They do anomaly detection on wind turbines, and they're checking for excessive heat and vibration and that type of thing. And if you have really strong processing at the edge, if something's going really wrong with wind turbine, those things are really expensive. You don't want
Yes.
to blow up a bearing or something like that. Well, they could just shut it down immediately.
Yeah, that is true. And then of course image classification is another useful, because these devices have gotten more and more uh, powerful, that it can not a lot of a lot of it cannot classify as much as compared to like those big machines, or even a cell phone can classify more as compared to these tiny machines. It's very limited because of the size of the model that you can deploy to these machines. But if you're only detecting, maybe 5 to 3 items, maybe that's should be good enough. So depending on the application. And one of the problems out there is there's different, manufacturers of these boards, and not just manufacturers. There's also the clock speed, the sensors, all these different cameras, and there's all these different possible things that you can the each one of these devices. So whenever you're building your project, um, you need to focus on certain type of device that is available. And then of course it's harder to convert from once you build the model, and it's only going to run for that device and not. So there's other solutions on how you would do that. But that's nice. And then today I want to talk a little bit about this Wio terminal. And this Wio terminal is what I'm going to use for my demo. The reason why I use this is because it has a Wi-Fi connection. It has good enough flash. It's running ARM Cortex. It has. I'm going to use the accelerometer data that they have here, and then it just connects. Well, it's just easy to use to be able to do some programming. And the makers of Wio Terminal, they worked with this. They have this CodeCraft that is a graphical programming platform that is using Edge Impulse. If you're not familiar with Edge Impulse, they are the ones that are building a lot of the optimization for these edge devices and how you can run machine learning. They can do some of the training out there. And the reason why I also chose CodeCraft is because it's a good way for developers that are not familiar with AI, but just to kind of get the flow of what's actually happening without the complexity of of the other systems that's needed. So this is what CodeCraft would look like, and then they have this Wio terminal that has the TinyML. And so there are 4 things that you need in order to create the 4 things that you would need in order to deploy a machine learning to one of these devices. First is you create a model, and of course you have acquired data, and you upload some data to be able to train them. And once you train it, it would build a model. And once the model is created, now you can integrate it with your application. In this case, we'll do this we will integrate it with our application. So let's do a quick demo on how that looks like. Let's see if I can. This one. Okay. I need to. Okay, I need to exit that. And then I would go to my window. Okay. See if I can get to that. And now I have some items here. Okay, so the first thing that you do, I'm just going to walk through is you would go to this model creation, and in this model creation would initialize the model that you wanted to create. And once you have that model created, you go to a data acquisition phase, where in this case, I have to create you know, a way to be able to collect sample data from my device. So this is this is a simple program that what it does is if I press the button A, it would start collecting some of this sample data from this device. And my device that I'm going to be demoing today looks something like this. Let me see if I can showcase that. See, this is the device. This is the Wii U device. And when you press button A, it would collect 5 seconds of flip data. So that's why it's going to label it. And if I press B, it would collect the wave. And then if I press C, it would be idle. So let's see if I can do that. I have a video demo on that, what that looks like. Let's see if I can. So I looks like I don't have that demo, but what it's going to do is once you click buttons, it would record the accelerometer data and it would assign it. It would label it as flip. And, or like in this case, you would do wave. So you would, what you do is you would go in, shake it, and then it would start recording some. So you press the button and start recording. So once you start collecting the data, and this is sample data, notice how the raw data, there's 3 axes, and it's not, you can see that it's idle in its idle state. In the flip state, notice how there's a pattern. And then on the wave state, a totally different pattern. So notice how it's possible, looking at this, it's possible that you can differentiate the what's happening on this device.
Can you show them that little device and what the flip and the wave actually look like?
Yeah. So let's do that.
This is the device. It's actually
so this right is here. The device, and then if I start moving it, notice how it says wave, and then if I start flipping, notice how it would say flip.
Yeah.
So that's, and then of course I'll go back to idle. So those are the different data that got collected. So once I do that, I would collect the data and they would send it to the to Edge Impulse. And Edge Impulse, what it does, it splits the recorded 5-second data. It would split it into smaller chunks. And then based from that, because you have the model, then it can do a neural network in order to build up and train it for machine learning workload. And then once it does that, it also optimizes it to where it can run on these tiny machines. Because typically when you run a machine learning model and you retrain them, it would be the precision is might be higher, but once you convert it into something that would run on these devices, you have to make sure that it will run on a not a floating point, or maybe a smaller type of numbers. So it'll do that. And then right here at the bottom, it kind of gives me how long will it take to do some inferencing on this certain device, what is the RAM usage, and then the size of that flash. So once it does that, you can have a program. Now what we're going to do is we integrate it with our application, and this is how, a high level point of that integration, where in this case, you have a model, you load that model. What happens is the model that got generated from Edge Impulse, it will get loaded to this other application, and this model is it's a set of arrays or data or that just get integrated into your C++ application. And you would load the data in memory and then read the accelerometer data, and based from that accelerometer data, pass it through an inferencing engine, and it would give you the result. So let's see if I can do a demo with that one. So this is my device. Let's see if I can load my video terminal here. This is the project I was working on. So I know I can connect the device from here, and then I can have the serial monitor. So this is the program that you're just looking at, and then I get the serial monitor. Notice how on this application, it will just continuously run. There's a loop that continuously run, and that's what it's doing here. So if I read the serial monitor, it would load the model, it would pass it through this inference engine, and then it would try to detect what type of action is happening right now. So if I, just to kind of show you what's going on, if I do shake it a little bit, notice how the wave values, let's see if it'll show up here. Or here you go. It's going to be higher. See how it says the wave is higher, and it will pick the largest one, and that's what it's going to display. If I flip, and notice how flip is 97. So you would select whichever is the highest amongst the three, and that's what it would return. So that's how it's trying to guess what's going on. So if you think about this, right, and what just happened, if you have to program this manually, yes, it's possible that you can kind of detect what is an idle state, what is a wave state, what is a flip state, and looking at the this accelerometer data. But what this one did was it was able to collect some data from 5-second data and label them what type of action it is, and then retrain or train the model, and based from that model that gets created, it gets sent to this device, and then it can run locally continuously as it flows. Any questions, Jack?
No, I don't think so. I mean, I think to summarize it up, what Ron just showed you guys was that one of these little tiny devices, he can collect real sensor data. In this instance, it's an accelerometer, and it could have been a wide array of sensors depending on the kind of device that he was using. And this is basically how you're seeing things like self-driving cars, smart cities, and industrial automation. This is how they're doing it. They're using sensors out on the edge. They're collecting the data, and then they're running AI models utilizing that data to make crisp decisions about actions that need to be taken. And I thought this demonstration, when I saw him do it, was a very simple example of how doable this actually is. I mean, it doesn't take a wide thought stream to gather all this in and realize that in just about any instance where you need to collect data and have a machine be able to make decisions and take action, it's doable with today's technologies.
Yeah, that is true. I completely agree with that. And of course, if I'm going to run this, and if it's something that is not trained, like how I'm doing right now, it's going to try to guess as much of what is that type of action? And of course, even though it's not trained for that, it tries to guess as much as it can. And so that's the beauty of it. And so because there are some items that we may have not trained it, or outside of its training boundaries in a way, that they might be able to discover because of that.
Well, you can imagine eventually, we'll have, using technologies like this, we'll have fighter planes that completely fly themselves. I mean, completely fly themselves and outfly humans. It's because they're going to have every sensor under the sun under there, and because they don't have the human limitations of G-force and things like that, they'll be able to run off the sensors, make crisper, faster decisions, and be much more effective fighter jets. And it's just that's a military application, but the industrial applications are countless. And
I agree.
You can see the impacts that AI is going to have from this.
Yes.
And that's really what I was looking for today. And I think you did a great job demonstrating it, just like you did when I first saw you do it. It's I really appreciate you doing this today. I think one of the things I'm trying to get from this is that there are people watching this podcast will be people all the way from CEOs who are trying to get an idea of what AI can actually do for them, to people who are deciding to major in computer science and then data science and become a data scientist. And understanding the possibilities is the first step. It's hard to create innovation if you don't understand the art of the possible. And that's basically what you're demonstrating here, is the art of the possible with AI and sensors.
Yes, definitely. That's what I want to showcase. And I do want to, I'm not a data scientist. I enjoy learning more about AI. And as I go through each one of the, especially on the edge side of it, the person that wanted to get into these kind of devices have to kind of, just give the idea of what is it, what is the technology, what is best used for, and getting that possibilities out there, and what is available right now.
You bet. Yeah, it's exciting. I know for us, for Vodem, I'm actively, looking at opportunities in industries that we work in to be able to use these technologies to help companies perform better. And the opportunity is certainly there, and it's a brand new frontier. Obviously people have been doing this for a while. If you look at the self-driving cars and how far along they've come, Tesla, people have been out there doing edge computing using AI for a while, but I think it's about to really take off. And I'm hoping that this helps some really innovative young person that is that has ideas for what they can do, that this helps them believe in their visions and go get them.
Yes.
So, that's really what I wanted to get out of today for people watching the podcast. And I think that you definitely delivered, and I really appreciate it, Ron. I appreciate you doing the session with us. And I all look forward to doing another session with you sometime in the future. We'll have some new things to talk about maybe, and we'll do another one.
Definitely. Yeah, definitely.
Hey, well, listen, thanks very much for your time today. I appreciate it very much. And of course, I'll talk to you soon. We both live here in Dallas, so I'll be seeing you.
Yes. Anytime. I appreciate you.
Okay, thanks. You take care.
Bye.